Hello everyone, welcome back to my top-down shooter tutorial. In this video we will start working on player and enemy stats. To do this I'll be using the gameplay ability system. This video will include a little bit of C++, but don't worry, it's not as hard as you might think. Before we dive in, let's quickly talk about GAS. The main strength of the system is how it simplifies attribute management and effect application. For example, if character is poisoned for a certain amount of time, we don't need to manually control that in code. Instead, we can simply apply an effect that runs for the desired duration. And one word before we start. I know some of my viewers might have skipped the instruction from the first video about setting up the project as C++. If you have some problem with setting up C++ for Unreal Engine, I've included a link to the official guide in the description. And now let's get started. First, I recommend disabling live coding in the engine settings. This will prevent the engine from recompiling every time you make a change in code. Next, open the plugins window. Search for the Gameplay Abilities plugin and enable it. Once it's added, restart the editor. After the editor restarts, click on the Tools panel. Here at top you will see two buttons, New C++ class and, in my case, Generate Rider project, since I use Rider. If you are using Visual Studio or another editor, you will see your editor. If the Generate Project Files button is grayed up, don't worry, it will become available after you add your first C++ class. Now let's add a new C++ class for the character. Name character class TDS character. Make this class public and place it in a subfolder named character. Once the file is added, close the editor and open the Visual Studio project. Next, open the build.cs file. And add gameplay abilities to the public dependencies. After making this change, I recommend closing the project and right-click on the Unreal Engine project file and select Generate Visual Studio Project Files to update the solution. We have set up the Gameplay Ability System plugin. Now open your Visual Studio project and run it in the debug mode. This will launch the Unreal Engine editor. Once editor is open, let's add a new C++ file for the attribute set. Select attribute set as the parent class, name the new class TDS attribute set. And place it in a subfolder named GAS. After the file is added, switch back to your code editor and stop debugging. We will start with the attribute set. Open the TDS attribute set H header file. First, at the top of the file, include ability system component. Next, let's define a macro for simplifying property handling. Use the define directive and name the macro attribute accessors. This macro will take two inputs, class name and property name. In places where we use this macro, it will be automatically substituted by another macros, such as gameplay attribute property getter with class name and property name as inputs, gameplay attribute value getter with property name, gameplay attribute value setter, with property name 2, and gameplay attribute value initer. With property name. Using this macro will make it much faster to describe properties. Preprocessor will replace that macros with useful functions for our properties. For example, the gameplay attribute value setter macro updates the property using ability system component, so we don't need to write the logic manually every time. Next, let's describe the class. Inside the header file, add the public section, and in this section add a constructor for the class. The constructor should be a function with no export type, just the name of the class. getLifetime replicated props function. If you're unsure of the function exact signature, you can quickly find it holding Ctrl and clicking on the parent class name. This will open the attribute set class, which inherited from uObject class. If we open uObject definition, we will be able to locate that function and copy that signature directly. Finally, make sure to add a override at the end of the function declaration to indicate that we are overriding it. Let's add a property for health. First, declare it as fGameplay attribute data health. Next, use the attribute accessors macro. For the first input, use UTDS attribute set. And for the second input, use health. This will generate useful functions for working with the health attribute. Now above the field, add the uProperty macro. Set its parameters to blueprint read-only and replicate it using, which requires a function. For replication, create a function called onWrapHealth. Function should take a reference to fGameplay attribute data, representing the old health value, and make the function const at the end. Let me pause for a moment to explain what's happening here. The void keyword is a function's return type, and void means that function doesn't return any result. The ampersand means we are passing a reference to the value instead of making a copy. The const at the end of the function indicates that the function doesn't modify the state of the object it belongs to. Let's now add the uFunction macro. This macro exposes the function to Unreal Engine replication system, allowing it to be used in blueprints. Now go back to the health attribute and add the function to replicate it using. Also add the health to the vital category. Now we have set up the health property. Let's add the max health property. To do this, simply copy and paste the health property and function. Then replace health with max health in the pasted code. If you are using Rider, you can quickly generate the definitions for these functions. However, for this class, I will show you how to add the definitions manually. Open the TDS attribute set CPP file. First, let's implement the constructor. To do this, write a name of the class, followed by a double colon, and then the name of the class again. Remember, the constructor must have the same name as the class. Inside the constructor, we'll initialize health and max health. Use init health to set the initial health value to 100. And do the same for max health, using init max health, also setting it to 100. To implement a function, first write the return type, followed by the class name, then a double colon, and finally the function signature. We'll use this approach to implement the getLife props function. At the start of the function, call super double colon getLifetime replicated props, which is the parent function call but written in C++. Next we need to set up replication for the properties. For this use, do rep lifetime condition at CFI macro. The first argument is the class name, the second is the property, and the third argument is a replicated condition. For example, cont none means the property will be replicated to all clients. Use rep notify always to ensure the replicated using function is called every time the property is replicated. Next, let's implement the replication functions for health and max health. Inside, use gameplay attribute rep notify macro. The first argument is the class name, the second is the current value, and the third is the old value. The macro is necessary to update the property in ability system. And repeat the same steps for max health. Open the characters header file. We need to use an interface from the ability system. So include ability system interface.h. Next, after a character in the class definition, add public ability system interface. Now open that interface. Usually you can use Ctrl-click on the name. And copy the getAbilitySystem component function. Paste it into the character class inside the public section. Then replace =0 with override. Now go to the protected section and add a pointer to your ability system component, named ability system component. Mark it with the uProperty macro, using visible anywhere, and blueprint read-only settings. Move this property to the abilities category. Next, add the pointer for UTDS attribute set, named attribute set. Using the same uProperty settings as ability system component. Last, you create a function called showDamageText which takes a float argument named damage. For the uFunction macro of that function, set the parameter blueprint implementable event, so this function can be implemented only in blueprints. Now let's implement the functions. For getAbilitySystem component, simply return AbilitySystem component. And we don't need to implement showDamageText in C++ because we will handle it in blueprints. Next we need to implement the constructor. Inside the constructor, call createDefaultSubObject for type toAbilitySystem component to create the AbilitySystem component, using the name AbilitySystem component. Then assign this component to the AbilitySystem component property. Enable replication for the component, and set the replication mode to mixed. Finally create attribute set with createDefaultSubObject for TDS attribute set. Lastly, inside begin play we need to add a listener. This will be a temporary solution for now. We need to call getGamePlayAttributeValueChangeDelegate on the AbilitySystem component. With health attribute from the attribute set. Then call addLambda to attach a function. Inside the lambda, we initialize the function. First in square brackets, set this to reference the current object. Next define the function argument. Which will be constant reference to f_onAttributeChangeData. Inside the function, check if data new value is less than old value. Call showDamageText, passing the difference between old value and new value. And the C++ code is ready. Now run the project in debug mode. Open project settings. And search for gameplay tag list. Click on Manage Gameplay Tags. Click Pause button. For the source, select default gameplay tags and add a new tag named Damage. Next, inside the Blueprints folder, create a new folder called Gas. Inside this folder, add a new class inherited from gameplay effect, and name it GEDamage. Now let's configure this effect. For modifiers, add a new modifier and select the health attribute. Set the modifier operation to add base. Next, open modifier magnitude, change magnitude calculation type to set by color. For the data tag, select damage. Next, open the Blueprints character folder. Create a new blueprint inherited from the TDS character and name it VP character base. Open the class And inside event seek, we will display the current character health, since we don't have a HUD yet. Use print text to display the information on the screen. For in-text, use format text and structure it like this. Name, colon, current, /max. For the name placeholder, use the display name of the current object. Get attribute set. For current, retrieve the current value of health. For current, retrieve the current value of health. For max, retrieve the current value of max health. Finally, set the duration to delta seconds. Next, let's implement show damage text. We already have a damage text implementation inside BP enemy. So open BP enemy and copy the existing implementation. Now paste it into BP characters base show damage text. Don't forget to connect the damage pins. Now open the functions folder and create a new function library. Name that function library apply damage to character. Open the newly created function library and create a function called apply damage to character. This function should have two inputs: character of type BP character base and damage of type float. Next, get the ability system component of the character. And promote it to local variable target ASC. From target ASC, call make effect context, which will create the effect execution context. Now call make outgoing spec. Set the gameplay effect class to GE damage and set the context input to the result of make effect context. Next, take the result of make outgoing spec and call assign text set by color magnitude. For the magnitude, set it to the negative damage, since we are decreasing health. For the data tag, set it to damage. Finally, call apply gameplay effect spec to self on using the assigned result as a spec handle. Next, we need to reparent the character and enemy classes. First, open BP enemy. Click File and select Reparent Blueprint. Choose BP character base as the new parent class. Now remove the old code responsible for reacting to damage. Next, open BP character and do the same. reparented to BP character base. And also remove the old code responsible for reacting to damage. Also I'd like to rename BP character to BP player for better clarity. Now the only thing left is apply damage using our function. First open BP bullet. And replace the existing apply damage logic with a function from our function library. Next open PP zombie. Find applying damage. Here cast the hit actor to BP character base and call apply damage to character. Don't forget to set the damage value. Now open BP weapon. In the section where we process melee damage, cast the hit actor to BP character base. And call apply damage to character. Again, make sure to set the damage value properly. Lastly, before testing everything, open BP player and inside event seek call parent function. Now run the game and check how it works. We can see that the player takes damage and the damage text appears. The zombie also takes damage. But currently we can go into the negative HP. We will fix this issue by clamping health in next video. Thank you for your attention and see you soon!